All right, so today, school, our classes rather, ended at 10:50. So we didn't get to move on to the next topic, which was mapping rules. So before we get on to mapping rules, I'm just going to go through the question that I gave you as your homework. All right, so the first question says write the elements in the mapping diagram above as ordered pairs. All right, so all you have to do is just write the x values separated by a comma with the y values. So let's start. So it's going to be, the first ordered pair is going to be 2 maps onto 3. So it's going to be 2, comma 3. And then you're going to have, all right, I'm just going to go ahead and write this relation as a set of ordered pairs. So our first ordered pair is 2, 3, 5, 6, 4, 10, and 1, 20. Then we close that with a curly bracket. All right. Next question says write the elements of the domain of this relation as a set. So we're going to be writing the elements of the domain, and it has the domain circle already. This circle is labeled as the domain already. So you know that the domain is going to be the set of x values in a relation. So it's going to be 2, 5, 4, and 1. And that's it. All right. Write the elements of the range of this relation as a set. We're going to do the same thing. So the set of y values in a relation is the range. So it's going to be 3, 6, 10, and 20. All right, so that's it for the assignment. Now let's move on to discussing mapping rules. All right. So what we're going to be doing today is recognizing situations in which there is a relationship between two number sets, or where there is a relation, and using a mapping diagram to show a number relationship. All right, let's start with this first example. Now it says this tree was planted on Harbor Day 20 years ago, and the seedling, which is 1 year old, is planted on the same day, June 5, which is also World Environmental Day. How can we show what ages they will be each year they get older? All right, so we have this big tree here and we have the seedling here. Now it says that it was planted 20 years ago. Sorry about that. This tree was planted 20 years ago, and on the same day, June 5th, 20 years later, a seedling, a 1 year old seedling was planted. So when this tree is 20 years old, this seedling is 1 year old. All right, so we are asked the question, how can we show what ages they will be each year they get older? Now, like we said before, there are many ways to represent a relation, right? And it's basically asking us to show the relation or the relationship between the age of the tree and the age of the seedling. So how can we represent that? Now, the easiest way to represent a relation is a table. We have more than one ways to represent a relation, but in my opinion, I think that a table is the easiest way to represent a relation. So let's go ahead and make a table. All right. So we have our table. Now, what are we going to do with the table? It's asking us what ages they will be each year they get older. So we want to show how their ages change as each year progresses, or as each year passes. So let's start with year 1. So what age was the tree on June 5th, the same day 20 years ago, right? All right, so we're going to start by having a column with the age of the tree. And then we're going to have another column with the age of the seedling. Right here. All right, so what age was the tree the first day? The first day the seedling was planted. The tree was 20 years old, right? Now, when a tree is 20 years old, the seedling is 1 year old. All right, so as each year progresses, what ages are they as each year progresses? So this is year 1, 20 years old, 1 year old. The next year, it would be 1 extra year, right? So it's going to be 21 years old. Now, when this tree is 21 years old, the next year, this seedling is also going to increase by 1 year in age. So it's going to be 2 years old. All right, let's do one more where we have the tree being another year old. Another year passes, so it's going to be 22 years old. And the seedling would also be 1 year old. 1 extra year old, and it would be 3 years old. All right, so we can see the relation here. Now, we have our values in the table, right? But we don't have our relation as yet. We need to find out or state what the relation is. All right, so we can say that the relation R is going to be, all right, we can write it as X maps onto, right, that's what I call that. X maps onto trying to move this alright, that's fine, it's fine where it is. X maps onto, now what did we do to these values over here to get these values over here? What did we do to the what can you do to the tree's age to get the seedling's age? Let's say we want to find the age of the tree when it's 100 years old, if the tree can live so long. Instead of listing all of these values from 20 up to 100, which would be very long and tedious, we can just go ahead and state the relationship between the tree and the seedling. So let's say we wanted to find out how much or how old the seedling would be when the tree is 100 years old. What's a shortcut way of doing that? So a shortcut way of doing that is just simply stating the relation or the relationship between the tree's age and the seedling's age. So what did we do to these numbers over here to get the seedling's age? All right, if you notice, you can subtract 19 from 20 to get 1. You can subtract 19 from 21 to get 2, 19 from 22 to get 3. So we can say that X maps onto X minus 19. And that's the relation. So that is how we can show what ages they will be each year they get older. And that's the relation. All right, so moving on to another example. All right, it says, let's look at this mapping diagram. What do you notice about the numbers in the domain and range? What do you have to do to the numbers in the domain to get the numbers in the range? All right, when we use a shortcut method for finding the values in the range or finding the values that we would put in the range column or the y column, because remember the range is the set of all y values in a relation. We call this the mapping rule. So it's just simply a shortcut. You put in the numbers, you put in the x values or the values in the domain, and you get the numbers for the range or the y values, right? So let's just move on to the example so I can show you how exactly it is done. All right. Let's figure out the pattern, just like what we did before. We're going to figure out what did we do to these numbers over here to get these numbers over here. All right. 1 plus 1 gives you 2, right? All right, let's try it with this other number. 3 plus 1 gives you 4. 5 plus 1 gives you 6. 7 plus 1, 8. 9 plus 1, 10. 11 plus 1, 12. All right, so we notice a consistent pattern. So we can say that x maps onto, trying to get the arrow, x maps onto x. So what did we do to the x to get the values? What did we do to the numbers in the domain to get the numbers in the range? We added 1, right? So you're going to take your x value and add 1. And that's it. You have your relation. You're showing the relationship between the numbers in these two sets. All right, another example is going to be this one. All right, so it says describe the relationship between the elements in the domain to the elements in the range of this relation. Now we want to figure out the mapping rule, or the pattern that we use, or the shortcut that we use to get the numbers in the range, right? All right, let's look at this. What do you do to 2 to get 6? You multiply it by 3, right? Let's see if it works for this number. 5 times 3 gives you 15, okay. 10 times 3 gives you 30. All right, so we have a consistent pattern. So all of our x values, or the values in the domain, we multiplied them by 3 to get the values in the range. So our mapping rule is going to be, and like I said, there are many ways to represent a relation, but this one is just a mapping rule. But sorry, this one is just a mapping diagram, but the mapping rule can be found in whatever way it's presented. If it's presented in raster form, if it's presented as a table, you can still use you can still find the shortcut, which would be your mapping rule. So x maps onto, so what did we do to the x values over here to get these values over here? We multiplied by 3. So our mapping rule is x maps onto 3x. And that's it. Next one. All right, we have these two sets right here. And it says, what is the mapping rule for the diagram above? All right, same thing. We're going to see if we can figure out the pattern. So 1 maps onto 2. What did we do to 1 to get 2? We can add 1. All right, let's try it with the number here. We can't add 1 to get 4, so it must be something else. But we can multiply 1 times 2 to get 2, and we can multiply 2 times 2 to get 4. But it doesn't work for this one, because we can't multiply 3 times 2 to get 9. So what is it? Well, we can say, wait, this one should be 1 actually. Sorry about that. I'm just going to put a 1 over it. Should be 1. All right. So none of those work. So let's think. 2, 4, 3, 9. If you notice, we can square 2 to get 4, and we can square 3 to get 9. We can also square 1 to get 1, because 1 times 1 is 1. All right, so we have a consistent pattern. So that means our relation is going to be x maps onto all right, this arrow is a bit skinny. X maps onto x squared. So I'm trying to get it to be, hold on. All right, I'm just going to use that to represent squared. And that's our relation. Now, with this one, it's not really in the mapping diagram as yet. We're going to have to put it in the mapping diagram first, and then we figure out the mapping rule. Or if it's easier for you to figure out the mapping rule while it's written in raster form like this, it doesn't matter. So as long as we figure out the pattern. All right, so we have a set of values here, a set of ordered pairs rather, which is our relation, right? So let's start by plotting all of our x values in the domain circle, which is this circle right here. So it's going to be 18, 10, 20. Feel like I'm running out of space. 9, 16, and I'm going to do that over because it's running out of space. I'm going to put it up here instead. 18. That's going to be 10, 20, 9, 16, and 6. All right. We have all of our x values, 18, 10, 29, 16, 6. All right. Now let's put all of our y values in the range circle. So it's going to be 12, 4, 3, wait, did I miss one? Yes, I did. It's actually 14. That should come first. 14, 3, 10, and 0. All right. So we have all of our values for the domain. Let me not forget to state which is which. So this is the domain circle, or we can say x, whichever one suits you best. X, you can put x and y, or domain and range. All right, now last but not least, our arrows. Almost forgot those. So 18 maps onto 12, 10 maps onto 4, I'm trying to fix that. I'm just going to use the pen instead. Ten maps onto 4, 20 maps onto 14, 9 maps onto 3, 16 maps onto 10. That arrow isn't looking so right. And 6 maps onto 0. Sorry about the wonky looking arrows. All right, so now that we've put all the values in our mapping diagram, let's figure out the mapping rule for this relation. Now, what can we do to these values in the domain circle, or the x values, to get the values in the range circle, or the y values? All right. What can we do to 18 to get 12? We can subtract 6, right? All right, let's see if it works for this number. 10 minus 6 is 4, yes. 20 minus 6 is 14, 9 minus 6 is 3, 16 minus 6 is 10, and 6 minus 6 is 0. All right, so we notice a pattern that works for all of the numbers. So we can say that our relation is going to be, our relation R is x maps onto, trying to find my arrow, x maps onto x. So what did we do to the x values? We subtracted 6, so it's going to be x minus 6. And that's it. So like I said before, all you have to do is notice the patterns. What did you do to each value in the domain circle to get the value in the range circle? Or what did you do to the X value to get the Y value in the ordered pair? All right. I'll be posting the assignment on Google Classroom, and feel free to ask any questions if you have any questions in regard to mapping rule or anything that we did before.